Hi children, good morning. In this video, you have to learn number theory. This is the one of the most important chapters in 8th class. Once upon a time, this number theory and geometry also includes in IIT syllabus. From 5 to 6 years onwards, this was removed. But in terms of Olympiads, important one. In this chapter, we have to discuss these subtopics. First, forms of number, characteristics and forms of numbers. Next, units digit concept. Units digit. Next, base representation theorem. Base representation theorem. Otherwise, scales of notation. Both are same. After base representation, divisibility rules. Next, division algorithm. This is different from algebraic division algorithm. Next, number of divisors. Sum of divisors, product of divisors. Next, greatest integer function. Greatest integer function or step function. Greatest integer function or step function. Next, congruences. These are completely different from geometrical congruences. Next, Fermat and Fermat's little theorem. Next, Wilson. Division algorithm is nothing but the Euclidean algorithm. Euclidean algorithm. These chapters we have to discuss in this number theoretical part. In addition to this, we have induction, mathematical induction. Mathematical induction. These subtopics we have discussed in this chapter. The first one, forms of the numbers and properties of numbers. In our number system, we have different types of numbers. We have different types of numbers. We have natural numbers. 1, 2, 3, 4, and so on. All counting numbers are natural. Whole numbers. 0 along with the natural numbers are called whole numbers. And integers. Zero along with the Next, rational numbers. Numbers which are in the form of p by q, where q not equal to 0 and pq belongs to integers. What is the difference between rational number and fraction? The numbers which are in the form of p by q are also called fractions. Here the difference is where pq belongs to whole numbers. In case of fractions, pq belongs to whole, but in case of rational numbers, pq belongs to integers. There are no negative fractions, but in case of rational numbers, negative also we have. Next, irrational numbers. Numbers which we can't write in terms of p by q are called irrational numbers. Numbers which we can't write in terms of p by q, which are not in the form of p by q, are called irrational numbers. Irrational numbers. Next, real numbers. The combination of rational and irrational are called real numbers. Real numbers. Here we have imaginary numbers also. Imaginary. Root minus 1 is the origin of imaginary numbers. It is denoted by I. Mean I square equal to minus 1. I square equal to minus 1. Next, complex numbers. Complex numbers. Numbers are in the form of a plus ib. Here a, b are real numbers. Okay, numbers which are in the form of a plus ib are called complex numbers, where a and b are real numbers. This is our number system. Okay, natural numbers. All counting numbers are called natural numbers. Natural numbers along with 0 are called whole numbers. Integers, positive, negative along with 0. Rational, the numbers which are in the form of p by q are called rational numbers, where q not equal to 0 and vq belongs to z. Irrational numbers. The numbers which we can't write in terms of p by q are called irrational numbers. Next, real numbers. Rational and irrational togetherly will be treated as real numbers. Imaginary. The numbers are in the form of root over minus 1 are called imaginary numbers. Complex. The combination of rational and real and imaginary. In a plus ib form, where a and b are real. Here, natural numbers, whole numbers, integers, rational, along with irrational are real numbers. This is the flow chart of numbers. Flow chart of the given numbers. Okay, here, what is the smallest natural number? 1. 1 is the smallest natural number. What is the greatest natural number? Can't be determine. What is the smallest whole number? 0. All natural numbers are whole numbers. All natural numbers are whole numbers. The smallest whole number is 0 and the greatest can't be determined. Next, the number of natural numbers between A and B. Number of natural numbers between A and B. B minus A minus 1, where A less than B. Natural numbers between A and B. Number of natural numbers between A and B. B minus A minus 1. How many natural numbers are there between 1 and 100? They give 100 minus 1 minus 1. Mean 98 natural numbers are there. Between mean exclusive. Here 1 and 100 excluded. Between they are asked. That's why 98 natural numbers are there between 1 and 100. Sometimes they will ask how many natural numbers are there between 3 and 499. Mean 499 minus 3 minus 1. Mean 495 natural numbers are there between 3 and 499. Okay, next the number of natural numbers. The number of natural numbers. The number of natural numbers from A to B. From A to B. Between A and B mean B minus A minus 1. From A to B mean B minus A plus 1. B minus A plus 1. Here B minus A plus 1. They are asking from and to. That's why. Here also A less than B. A less than B. From A to B. Okay. In this way, we can find the natural numbers. For example, how many natural numbers are there between? From 1 to 100. Okay, from 1 to 100 they are asking. So here 100 minus 1 plus 1 means 100 natural numbers are there. Are there from 1 to 100. Here 1 and 100 included. From 1 to they are asking. In the first condition, between. That's where B minus A minus 1. Next, sum of first n natural numbers already we learned n into n plus 1 by 2. Sum of first n square natural numbers n square into n into n plus 1 into n plus 1 by 6. Then sigma n into n plus 1 by 2. Sigma n square n into n plus 1 into 2n plus 1 by 6. Sigma n cube n square into n plus 1 whole square by 4. Next, we are coming to whole numbers. We are coming to whole numbers. These are all applicable for whole numbers also. These properties are applicable for whole numbers also. Next, integers. Okay, integers of 3 kinds, 3 parts it has. Positive integers, negative integers along with the 0. Here z plus positive integers, z minus negative integers. along with the 0. Now, non-negative integers, non-negative means except negative. So, positive along with the 0. Positive along with 0. Non-positive means negative along with the 0. Here non-negative means except negative. Non-positive means except positive. 0 is neither positive nor negative. That's why that does not belong to. Now, intersection part of non-negative and non-positive, they ask me 0. Okay. Next, properties. Properties of numbers. Properties. Here we have closer, associative, identity, inverse, commutative. Distribute separator. Closer. In terms of all number systems I am explaining: natural, whole, integers, rational, irrational, real, whatever it may be. Till rational numbers enough, because we have first chapter rational numbers. Here closer, what is meant by closer property? Here A dot B equal to C. A dot B equal to C. For example, here A, B are natural numbers. C is also a natural number under any particular operation. Here dot represents plus, minus, into, divided. Dot represents plus, minus, into, divided. A dot B equal to C. Mean if A and B are natural numbers, C is also a natural number under any particular operation, then closer satisfies under that particular operation. For example, if you consider addition, sum of two natural numbers is also a natural number. It is true for all natural numbers. That's why natural numbers satisfy closure property with respect to the operation addition. With respect to the operation addition. For example, subtraction. Mean A minus B equal to C. A minus B equal to C. Difference of any two natural numbers is also a natural number. Then natural numbers satisfy closure property with respect to the operation subtraction. But natural number doesn't satisfy closure property with respect to the operation subtraction, because 2 minus 3 equal to minus 1. 2 is a natural number, 3 is a natural number, but the difference minus 1 is not a natural number. That's why natural number doesn't satisfy closure property. With respect to the operation multiplication, product of two natural numbers is always a natural number. So, natural number satisfy closure property with respect to the operation multiplication. Division. The quotient of two natural numbers is not a natural number. Here 8 divided by 16 they gave me. Quotient is 1 by 2. 8 is a natural number, 16 is a natural number. The quotient 1 by 2 is not a natural number. That's why it doesn't exist. So, likewise, for whole numbers, with respect to addition and multiplication, it satisfies. Integers. In case of integers, here A plus B, A minus B, A into B is also an integer. Here 2 plus 3 equal to 5. Minus 6 minus 3 equal to minus 9. Here minus 6 into minus 2 equal to 12. In the three cases, addition, subtraction and multiplication, again we will get an integer, because integers contain three type of numbers. Now only we discuss positive, negative, 0. If you subtract any two numbers according to the law of trichotomy, x and y are any two numbers, their sum or difference or product also gives the same. Okay, if you subtract any two numbers, three possibilities we have. X and y are any two numbers. If you subtract x minus y, if x is greater than y, positive you will get. If x is less than y, negative you will get. If x equal to y, 0 you will get. Mean here positive, here negative, here 0. If you subtract any two numbers, you will get these three situations, either positive or negative or 0. Next, in case of rational numbers, in terms of addition, subtraction, multiplication and division also, we will get the rational number. Mean sum of two rational numbers is also a rational number. Difference of two rational numbers is also a rational number. Product of two rational numbers is also a rational number. Quotient of two rational numbers is also a rational number. So in all the cases we get rational number. That's why rational numbers are closer with respect to addition, with respect to subtraction, with respect to multiplication and division also. Natural numbers and whole numbers satisfy with respect to addition and multiplication, while integers satisfy closer with respect to addition, subtraction and multiplication. But in case of rational numbers satisfy closer property with respect to addition, subtraction, multiplication and division. Next, associative property. Here A dot of B dot C is equal to A dot B dot C. Here dot represents the four basic operations: addition, subtraction, multiplication and division for natural, whole, integers and rational numbers. For rational numbers, sum of any three rational numbers gives the same result if you take in any order. Okay. For example, 1 by 2, 1 by 3, 1 by 4. Here 1 by 2, 1 by 3, 1 by 4. 12, 4 plus 3, 7, 6, 3 plus 2, 5. Here LCM is 12, 6 plus 7. Here 12, 2, 5, 7, 10, 3, 3 ones 3. So 13 by 12, here also 13 by 12. So rational numbers satisfy associate with respect to addition. With respect to subtraction, doesn't exist because the difference of two rational numbers. Mean here A minus B is not equal to B minus A. A minus B is not equal to B minus A. That is not true for any number system. Mean natural, whole, integers, rational, irrational, whatever the system it may be, it fails. A minus B is not equal to B minus A. So with respect to subtraction, that holds. With respect to multiplication, holds. Multiplication holds. 2 into 1 by 3 into 1 by 4 they give. Then 2 into 1 by 3 into 1 by 4. 2 by 3 into 1 by 4. Here 2 ones 2 by 12. Here 2 by 12. So with respect to multiplication also goes. With respect to these values. So association with respect to addition and multiplication is true. Next, identity. Identity. A dot something equal to A will by. Okay. With respect to addition mean A plus 0 equal to 0 plus A equal to A. With respect to multiplication mean A into 1 equal to 1 into A equal to A. These two identities we have for any number system. When you will get the same number while you are doing addition, if it is added to 0, then it is possible. That's why 0 is called additive identity. One is called multiplicative identity because you will get the 1 if any number multiplied with the 1. So these are identity properties. Identities with respect to addition and multiplication. There are no special processes for subtraction and division. Next, inverse. So in case of addition, A plus 0 equal to 0 plus A equal to A. Now only we got the result with respect to identity. Now A plus minus A equal to 0. Whenever you will get 0 in identity, that is called its inverse. For any number system, inverse for A is minus A, for 2 is minus 2, for 6 is minus 6. Now we need to check its existence. In identity and inverse are existences. For example, A plus 0 equal to 0 plus A equal to A. For natural number, there is no existence of 0. That's why it doesn't satisfy identity. Mean 0 is not present in natural numbers. In case of whole, integers, rational, 0 present. That's why there is an existence of 0. Means existence of identity, additive identity. Inverse. Here also existence. 2 is a natural number, but minus 2 is not natural. 2 is a whole number, but minus 2 is not a whole number. That's why there is no existence of inverse element with respect to addition. But with respect to multiplication, what is the inverse element? Mean A into 1 by A equal to 1. Because 1 is multiplicative identity, 0 is additive identity. For getting additive inverse, we want 0. For getting multiplicative inverse, we want 1. Multiplicative inverse is nothing but reciprocal. Means there is no change in its sign. Additive inverse means there is a change in sign. Plus given with minus, minus given with plus. Whatever the number it may be, plus given mean we need to change it into minus. Minus given mean change it into plus. That is only its additive inverse. In case of multiplicative inverse, there is no change in its sign. 1 is given mean 1 only its multiplicative inverse. 2 is given means 1 by 2. 3 is given mean 1 by 3. 1 by 3 is given mean 3. 2 by 3 is given mean 3 by 2. For 3 by 2, 2 by 3 is multiplicative inverse. For 3 by 2, minus 3 by 2 is additive inverse. Additive inverse are the multiplicative inverses. Commutative property. Commutative property. Here A dot B equal to B dot A. A plus B equal to B plus A minus B equal to B minus C. A into B equal to B into A divided by b divided by a. Here a plus b and b plus a minus b minus a into b into a divided by b divided by a. But here for any number system only these two are true. Okay, sum of any numbers, sum of two numbers in any array is the same result. In case of natural, whole, integer, rational, whatever the numbers it may be, their sum is the same if you take in any order. For any two natural numbers, for any two whole numbers, for any two integers, for any two rational numbers. Product also same. For any two rational numbers, the product of two rational numbers is same if you take in any order. If you take in any order, the product is same. That's why with respect to addition and multiplication, it is true. But in case of subtraction and division, it does not exist. Okay, these are the properties. Next, distributive property. Next, distributive. Distributive mean a of okay, here a into b plus c equal to ab plus ac. Plus mean plus, minus mean minus. Here a into b minus c equal to ab minus ac. Distributive property mean which involves two operations. In case of closure, associative, identity, inverse and commutative, with respect to any one of the operation only we have to check. But in case of distributive, two operations are involved. Here the first one, distributive of multiplication over addition. Here distributive of multiplication over subtraction. Over addition and over subtraction. Particularly left distributive law. Here a is placed left side of the bracket. Sometimes a is placed right side of the bracket. That is right distributive. Left distributive and right distributive. Both are wholes. In case of natural, whole, integers and rational numbers also distributive wholes. Distributivity of multiplication over addition and over subtraction also wholes. Okay. Here we discussed properties closure, associative, identity, inverse and commutative along with the distributive. Any number system satisfies these 5 properties with respect to any particular operation, then the number system is called a group. Number system is called a group. Mean natural numbers is not a group. Natural numbers is not a group because it doesn't exist identity and inverse. Whole numbers is not a group. It doesn't have any inverse element. Integers is a group with respect to addition because it satisfies closure, associative, identity, inverse and commutative property. Identity 0 is present in integers. Inverse for any integer there is an additive inverse for this one. Next commutative, a plus b equal to b plus a exists. That's why integers is a group with respect to the operation addition. With respect to subtraction, it's not a group. With respect to multiplication, it's not a group because a is belongs to integer. Mean 2 belongs to integer, but 1 by 2 doesn't belongs to integers. That's why. Multiplicative inverse 1 to present. In case of rational numbers is a group with respect to the operation addition. It satisfies closer associative identity inverse and commutative also. With respect to multiplication also it's a group, because rational number satisfy closure property with respect to the operation multiplication, associate with respect to the operation multiplication, identity with respect to the multiplication. That is one. Inverse also exists. A is a rational number, means 1 by A is also a rational number. For example, 2 is a rational number. 1 by 2 is also a rational number. Minus 3 is a rational number. Minus 1 by 3 is also a rational number. That's why rational number satisfies closer associative identity inverse and commutative. A into B equal to B into A. That's why satisfies all the properties. That's why it's a group. Rational numbers is a group with respect to addition and multiplication. Integers is a group with respect to addition. Okay? First chapter also over in our state textbook. The first chapter is rational numbers. Okay? Mainly they concentrate on properties. So once go through these properties and complete that one. Okay, tomorrow onwards we will discuss the subtopics: units digit, scales of notation, basic representation, congruences, Euclidean algorithms. These things we have discussed. Have a nice day. Bye.